this video lecture on QM method of minimization of Boolean expressions. This is Quine-Cluskey method. Earlier we have seen the K-map method, that is the pictorial method, and this method QM method is tabulation method of minimization of the Boolean expression. So let us start with the video. So the various steps, as we have also seen that the K-map is not suitable when the number of variable increases from 4. So for that, this QM method is very much suitable when the number of variable increases beyond 4 up to 5 and 6 variables. So the difficulty which we were facing in the grouping of ones in K-map, that is solved in QM method. So the various steps which are there in the QM method that are here, you please note down the QM method, the various steps for the minimization. Then we will see those steps by solving an example. So the step 1 is, first of all we have to list all the min terms in terms of in their equivalent binary form. We have to write all the min terms in their binary forms, right? For example, if m0 is given, m3 is given, we have to write m3 like this, 0 0 1 1 like this in the binary form. First step is this. Then we have to arrange all the min terms. Different min terms will be there in the question. So we have to arrange all the min terms based on the number of ones. Based on the number of ones in it. And step 3 is, we have to compare each binary number. Compare each binary number, each binary min term, binary number, and we have to form one group of those min terms. Form one group, that group to another, group to another, that differ in 1 bit position, right? For example, if it is 0 1 0 0 and another binary number is 0 1 1 0, so in the third bit it is different, otherwise all the 3 bits are same, that is 0 1 0 0 and 0 1 1 0. So this form a group because 0 1 0, these are same, but this third bit is different, so in 1 bit position they differ, so this form a one group. So in the third step we form a group of those binary numbers which vary, which differ in 1 bit position. Similarly, then those numbers which are left, we then compare each binary number and then we form a group which vary in 2-bit positions and so on, right? So this way we will form different groups. So then what we have also, we have to do, we have to put a dash mark, in the bit position where they differ. In this example it will come like this, 0 1 dash 0, right? Because 0 1 0, this first, second and last bit is same in both the numbers, third one is different, so put a dash here where they differ, right? So we have to do this, put a dash in those bit numbers also, right? So next we have to, so like this we have to apply all this process until all the binary numbers are covered, right? Then this will be step number 6. So then we have, what we have to do, then we have to list the unticked. We have to tick mark all the numbers which are covered. We have to tick mark all the binary numbers which are covered in the group. Then list the unticked prime implicant which are left, which are not contributed in any group, and form the, then we have to form a prime implicant chart. Prime implicant chart. And then in that chart, each prime implicant, prime, I am writing it like this, prime implicant pi is represented in row, and each min term corresponding to each prime implicant, a min term will be there, and each min term will be shown in the column, right? And we have to, you can mark cross or whatever, mark cross corresponding to each min term, corresponding to each min term and prime implicant. This way you can make a chart, and then search for the single cross column and select the prime implicant corresponding to that by putting star mark in front of prime implicant. Just note it down because it will be more clear from the example. Then search for multiple dot or multiple cross columns, right, one by one, and if the corresponding min term is already included, in the final expression, then ignore that min term. Means if all the min terms are included, then you can ignore that. Otherwise, include if a new min term is there. Like this, you can make a chart and write down the final implicant. So let us move on to the directly to the example. Let us see. Simplify f of a, b, c, d, summation m, this is for SOP, 0, 2, 3, 6, 7, 8, 10, 12, 13. 4 variables are there, and we are solving it with QM method. So step 1 is we have to write down their binary numbers. So min term and their corresponding binary. This is M0, M2, M3, M6, M7, M8, M10, M12, M13, right? And the binary equivalent 0 0 0 0. 4 variables A B C D. 0 0 1 0 0 0 1 1. 6 is 0 1 1 0 0 1 1 1 1 0 0 0 8. This is 10 is 1 0 1 0. 12 is 1 1 0 0. 13 is 1 1 0 1. So this is step 1, that is writing the binary equivalent. Step 2 is we have to make the groups according to the number of ones. So 0 is a single group. It is not added to anyone because it has no 1 in it. So M0. Then M2 is a single one with single one. 8 is a single one. No. So M2 and M8. So in the second step, M2 and M8 will be there. For the M3, two ones, M3, M6, M10, M12. So M for M3, M6, M10 and M12. They form the third group with two ones. Then M7 is third group with three ones, M7 and M13. Right? So 0 is there, M2 is there, M3 is there, M6 is there, M7 is there, M8 is included, M10 is there, M12 is there and M13 is there. So all are included. So this is your pair for 1. This is first step, this is second step. So I can write my second step on the next slide. This is step 2. I am writing it like this. Min terms. This is binary representation and my column B. This is M0 because with 0. Second was M2 0 0 1 0 and this is M8 with one single one. So this is one group and this is second. Third group was with two ones, M3 6 10 12. M3 6 10 and 12, right? 3 is 0 0 1 1, 6 is 0 1 1 0, 10 is 1 0 1 0 and this is 1 1 0 0. So this is my third. And last one was with three ones and this was M7 and M13. So I can write M7, M13. M7 was 0 1 1 1, 13 was 1 1 0 1. So this is my fourth group. So this is my second step. Step number 2. Right? Now from this step number 2 we will move on to step number 3. Now we have to make the groups which differ with bits only 1. See M0 and M2. They differ with only one bit. How? Because M0 and M2 only this second bit is different. So M0 comma M2 they differ in the third bit 0 0. Put dash on that bit which is differed, on which they differ 0 0 1 0 and 0 0 0 0, right? So in the third place they differ, so I am putting dash over there. And 0 and 8 also differ by one bit and that bit is first bit, right? So it is M0 and M8. So this is dash 0 0 0. So my 0 is included, 2 included, 8 is included, right? So when I am comparing 0 with M2 and M8, only one bit I have to take in, that difference should be of only one bit. So it will be compared only with 2 and 8. So 0 can't be compared with 3, 6, 10, 12 or 7 or 13 because there they have two ones are there. 2, 8 is now comparable with 3, 6, 10 and 12 because only one bit difference can be there. Now I am comparing 2 with other 2 with 3. Yeah, one bit difference is there. So I can say m2 comma m3, and they are differing by 0 0 1 0. So I can write it as 0 0 1 dash, right? Similarly m2 is with m6, 0 1 1 0, yes, m2 and so m2. So you have to compare each number with every number and make so many pairs, which so 3 is also, so it is 0 dash 1 0. Similarly m2 with m8, 1 0 1, yes, m2 with m8, sorry, m10, so it is 1 0 1 0, so it is dash 0 1 0. Then m12 1 1 0 0, no, m12 and m2 are not comparable because there are difference of 2 bits. And similarly m7 also not comparable. Okay, now come to the 8. 8 is comparable with 3, no. 8 is comparable with 6, no. 8 is comparable with 10, yes. m8 comma m10, it is 1 0 1 0, so 1 same 0 dash 0, right? 1 0 dash 0. Then 8 and 12, yes, m8 and m12. You can only write 8 and 12 and 8 and 10. So it is 1 triple 0 and double 1 double 0. So it is 1 dash 0 0 because they are differing on the second bit, 8 and 12, right? So now 12 is also covered. So now 8 and 7, no, they are not comparable because 8 and 7 are 8 and 7 are differing on all the 4 bits. 8 and 13 are differing on 3 bits. So 8 and 7 they are. Okay, now 3 and 7, 3 and 6, no. 3 and 10, no. 3 and 12, no. Right? So 3 and 7, yes, they are comparable. 3 and 7 because they are differed only on the second bit. So it is 0 dash 1 1. And 3 and 13, 0, no, not comparable because they are differed on 3 bits. Okay, then comes 6. 6 is comparable with 7. Yes, no, yes, 6 is comparable with 7, m6 and m7 because they are varying on 1 bit, 0 1 1 dash, right? Then m6 and m13, 1 1 0 1, no. Then m10, 1 0 1 0 and 1 0 1 1, 1 0 and 1 0, no, 10 is not comparable to anyone, right? 12 1 1 0 0, 10 12 is not comparable with 7, 12 is comparable with 13, m12 and m13, it is 1 1 0 dash, right? So 13 is also included. So all are in this step 3, included in this step 3. If any number in this step 2 is left and not included in the grouping in this step 3, then you have to, as it is, you have to write it in the step 3, right? So this is covered in the step 3. Now coming on to the step 4. For this step 4, now similarly you have to make the grouping of in this step 3 only with differing of the bits in itself. 0 0 dash 0 means now you have to see the difference of 1 in this group also. See 0 0 dash 0. Now see, 0 0 dash 0 means 0, 2 and 8 and 10 C. 0 0 dash 0. If 0 2, see these 8 and 10. 0 0 dash 0, when you compare these two, 0 dash 0 are same and they are differing only in the one bit, and that is the first bit. So these become a one pair. Similarly, you have to find out the other pair. 0 dash 0 0 0 dash 0 0 0. Anything? No. Dash 0 0 0 0. No. Then 0 0 1 dash 0 0 1 dash. And next is 0 dash 1 0 0 dash 1 0 0 dash 1 0. See this 3 7. 0 dash 1 0. 2 6 and 3 7. See this. See this. 0 dash 1 0 and 0 dash 1 and last one is different. So in the one place, that is the fourth one, they are differing. So we can put dash on the last bit. So it will be making a group. And any other group is there? See. So no other group is there. So this forms our step 4. Step 4. Step 4 will be, we will write like this: M0, M2, M0, M2, M8 and M10. M8 and M10, they are forming like this: 0 0 dash 0 and dash 0 dash 0. So it will be dash 0 dash 0, right? And another one is M2, M6, 3 and 7. 2, 3, 6 and 7. 2, 3, 6 and 7. So just like this you have to go on making the groups step by step. 0 dash 1 0, 0 dash 1 dash, 0 dash 1 dash, like this. So you can tick mark here, tick mark here, tick mark here and tick mark here. Like this you have done. This is now your step 4. So in this step 4, see if any group you can make. No. So you have to stop here and come to this step 5 to make a chart. Now A, B, C, D are your prime implicants. They means variables are your prime. They are called as the prime implicant, and you have to form a chart of a prime implicant. So these are the main terms which are given in the questions. So on the column side you have to write 0, 2, 3, 6, 7, 8, 10, 12 and 13. These are given in the question and you have to reduce it, right? So on the column side you have written the min terms, and on this side you have to write the prime implicants in the form of the terms, right? Now see, those numbers which are not ticked, you have to take it. See, in the column D, or in the we have not written the column numbers. So this was column B. In the step 2, this is column C, and this is column D. So in the column D you can see min term 0, 2, 8, 10, 2, 3, 6, 7 are included, right? So what you have to do, you have to write down the numbers which are there. Now, from the step 3, you have to include those things, those minterms which are not at all included in the column C. See, in the column 4, in the column D, 0 to 0 to 8, 10 are included. See, this is 0, 2 are included. Yes. 0, 8 are included. Yes. 2, 3 are included. Yes, 2, 3 is also there. Then 2, 6 are included. Yes, 2 and 6 midterms are there. Then 2 and 10 are there. Yes, 2 and 10 group is also, they are in a group, right? So 2 and 10 are there. Then 8 and 10 are there. Yes, 8 and 10 are also there. Then 8 and 12. 8 and 12, no, 8 and 12 are not there. So as 8 and 12 are not there, so you have write it down. So how you will write it? You will write here 8, 12, and in prime implicant it will written as it is 1 dash 0 0. So you have to skip this dash. This dash means it can be any, and this is 1 dash 0 0 means this is A B C D. So this is A dash B C bar D bar. So you will write, you will skip dash A C bar D bar. Clear? So you will write like this. Next is 3 and 7, it is there. 6 and 7, it is there. 12 and 13, it is not there. So you will also write, include this in the prime implicant chart. It is 1 1 0 dash. So it will be A B C bar. 12 and 13. So it will be A, B, C bar. So from the column C, we have taken this, right? So from the column D, we will take these two because it is including all the other variables which are left in these. We have taken it from the column C. So this is dash 0 dash 0. This means this is B bar D bar. So this is 0 to 8, 10 variables are included in B bar D bar. And the last one is 0 dash 1 dash. This is A bar C. And this is 2, 3, 6, 7 midterms are there. And it is A bar C. Right? Now you have to put cross on the midterms corresponding to each midterm. Right? This is A, C bar, D bar. It is 8 and 12 are included in it. Then 12 and 13 are included in the next. 0, 2, 8 and 10 are here. 2, 3, 6 and 7 are here. Clear? Right? Now you have to see for the single cross columns. You have to see the single cross columns where the cross is single. This is a single cross column. This is a double cross. This is a single, single, single. This is a single cross column, right? Now, for this single cross column, what you have to do? For this single cross corresponding to this single cross column, you have to mark the star for those prime implicants. This is not there. This is there. Star. For this already marked. For this already marked. For this already marked. For this it is there. So these three terms A, B, C bar, B bar D bar and A bar C. These are the essential prime implicants, and these are the minimized terms or the minimized min terms which are contributing to the result, and this is the your final answer. So I am writing on the next slide that the minimized form of expression is now equal to, you can write it like this, A B C D is equal to A B C bar plus B bar D bar plus A bar C. This is the required answer. Clear? So this way you have to, let me summarize it again, that you are given a problem with variables and with min terms like this. First step is you have to write the binary equivalent in the first step. Then in the second step, you have to make a grouping with ones, number of ones. In the first group, 0 number of ones. In the second group, 1 number of ones. In the third group, 2 number of ones. In the third group, 3 number of ones. Then in the third step, you have to make a pair of from those groups which differ by 1 bit. Right? Then you have to go on making the groups till they are there. Then, and the last step, you have to put a dash mark over where they differ on that place, right? By 1 bit, a single bit difference should be there. Then you have to pair those bits. Then in the last, when the grouping stops, then you have to come to the chart place. And in the chart place, you have to see those groups which are not included in this, and you have to see all the min terms are covered in this prime implicant chart. Then mark the min terms which are included in these min terms, and then put a cross mark for these min terms. Then on the column wise, see those columns which are having single cross, and corresponding to that mark a star for those min terms, and then these min terms write them in the SOP form, and these form the your final reduced form of the SOP Boolean expression like this. I hope you would have understood all this, and in case you have any problem, you can write your doubt in the comment box. So for your practice, I am giving you a problem for you. F is equal to summation m 0, 1, 9, 15, 24, 29, 30, 3, 8, 11 and 31, right? So this is a, as you can see, this is a 5 variable map. What you have to do, you have to solve this by yourself using QM method. So simplify using QM method. So this is your homework, you have to do it. For your ease, I am just giving here the solution. The solution will be A, B, C, D, E, and the answer will come out to be B, C bar, D bar, E bar plus A bar, B, D, E plus A, B, C, E plus A, B, C, D plus A bar, C bar, D bar. The only difference here is you are having 5 variables, otherwise all these steps are same. Okay, thank you.